Okay, I got cut short in that last video. We're going to finish up by adding a dynamic contour to come in and take that 10,000th off the walls that we left in the last operation. The reason we left that is because this will create what's called scalloping, which are just slight marks in the surface from where that tool comes in on those dynamic milling passes and machines out the material. From here, what I'm going to do is I'm going to go and add that dynamic contour. So I choose dynamic contour, machining regions. Again, we're using partial chains because we have open areas. I'm going to start here and exit here. I'm going to add another one to get this last corner, add a chain, and I chose right click to add the chain here. Once I have finished, up comes a dynamic contour box. I'm going to use the same 1/2 inch flat end mill, 5,100 RPM for aluminum, chip load of 0.001. The tool itself will take a heavier chip load. However, as I explained before, our machine will not take that heavy of a chip load. For this, because we're only taking 10,000ths off, I could chip load it much more, but I want a nice quality finish on here. Cut parameters. We want no material left. Step over, we're not worried about. If I was worried about step over, maybe I had machined with a really large tool at first, I could add in my step over here, especially if I was using a smaller tool. Contour on the walls, we previously machined this with the same tool, so we are not worried about any values here. We're not worried about depth cuts. The cutting length of our 1/2 inch flat end mill is 1 inch. We're only going 0.75 deep. Finishing. We are cleaning up a previous operation, so I'm not worried about finishing here as well. Lead in, lead out. If you want it, you need to turn finishing on. That will give you an extra pass. But the nice thing about dynamic contours is they will start outside of the material anyway and give a nice smooth transition in. The other benefit of dynamic contours, let's say it was machining an internal contour, areas like this corner, you would add tool passes in, as you see here, to make it more efficient in clearing out that material. I do want to add a breakthrough of 5,000ths. And I do want to make sure my retract is set to 2 to clear that clamp that we talked about using. We're going to go negative 0.75 deep. And when I complete the operation, let me turn everything off except that, we see it comes in, sweeps into this area here, finishes its contour, exits, comes way up to clear that clamp that we would put in, and then sweeps back in to finish that area. We had an optional stop after the PEC drill cycle to add in a clamp. And the reason for that, if I only clamped here and here, maybe here, here, and here, this would vibrate a lot. It would all not be held down. So by adding a clamp into this area, we create a very secure hold down by simply breaking up our operations. No need for multiple posts. The machine will stop after the PEC drill until the operator tells it to begin again. What this whole program looks like, we see our drilling, our dynamic milling, and then our finish pass. That was fairly quickly. If you follow this tutorial, you can slow down the speed of your Verify, but this is probably the most efficient way that we've learned so far to remove material and machine apart.